Welcome to our seventh and final video in our Polynomials unit. Today we're going to look at how to make our own magic. We were solving some polynomials yesterday, but we needed some magic factors to kind of help get us started. We're going to figure out how to find those factors ourselves today. So the question that we're going to explore today is where would the graph of this polynomial cross the x-axis. All right, well, first thing we know, x-intercepts are just another name for roots or solutions or zeros. They all mean the same thing. So if I'm looking for the x-intercepts of this graph, I need to figure out where our y would be 0. So we are trying to solve this equation, just making y equal to 0 to find our x-intercepts. Now, way back in the past, we were able to take out a common factor and start breaking this down. We can't do that now. That minus 6 means that x won't come out of all of these terms. Yesterday we had a factor to kind of help us get us started. And we took that factor, we used division to break down into that factor times a quadratic, and then we solved that quadratic to find the rest of our solutions. So the question for us today is, how do we make our own magic? How do we find these factors on our own without having one given to us? And the key is something called possible rational zeros, or PRZs for short. What we're looking for here is a list of anything that might work as a solution, as a zero to this polynomial. Anything that's possible to be a zero or an x-intercept or a solution to this equation that is a rational number. Remember, rational numbers are fractions, decimals that only have integers in them. So you might see a whole number, you might see a natural number, you might see an integer, you might see something like 1/2 or 0.25 or even 1/3, this is 0.3 repeating. But we won't see square roots, we won't see irrational numbers, we won't see imaginary numbers in this list. So to figure out all of your PRZs, all of your possible rational zeros, you have to look at your expression, look at your polynomial, and your PRZs are all the factors of your constant that's on the end of your polynomial, all the factors of those, positive or negative, divided by any factors that the leading coefficient might have. And I've got a couple examples for us to go through here, just listing out our PRZs. If I had this as my polynomial and I want to know, well, what are the possible solutions? What zeros might come out of this expression? I look at all the factors of my constant on the end. All right, my constant's 14, so the factors of 14, let's see, 1 and 2 and 7 and 14, and I think that's all of my factors of that constant. Remember, they can be positive or negative. So positive 1 or negative 1 could each be a solution. Positive or negative 2 could each be a 0. Positive or negative 7 could each be a root. Positive or negative 14 could each be an x-intercept. And then if I had any factors of a leading coefficient, I'd divide by them. Now my leading coefficient here is 1 for 1x cubed. So if I divide those by 1, the numbers are going to stay the same, obviously. And so this is my entire list of possible rational zeros, of all the possibilities that might work. Right? Different example, slightly different. Notice it's the same expression, only here instead of x cubed, we've got 9x cubed. So to list my PRZs, I'm still listing out all the factors of my constant at the end. So these factors will still be there, plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. But there will be more possibilities in this case because of that 9 out front. Your factors of 9, if you want to just kind of write them off to the side here, your factors of 9 are 1 and 3 and 9. So we have to take this list of factors of my constant, divide them by any factors that the leading coefficient has. So I can take all these and divide them by 1, that would keep them the way they are. But then I can also take all these and divide them by 3. So plus or minus 1/3 would be possibilities. Plus or minus 2/3, 7/3, and 14/3 are all possible rational zeros. These are rational numbers now. They're fractions with integers that might be zeros, might be solutions to this polynomial. I've also got to divide by the 9. So I have to go down and add another row here. All of these divided by 9. 1/9, 2/9, 7/9, and 14/9. So all of these are possibilities. This list tells me what my solutions might be to this polynomial. It doesn't tell me the answer, but it gives me a list of answers. So there's going to be a little bit of kind of trial and error, guess and check, sort of like when we factored. But rather than just pulling numbers out of thin air and seeing if those numbers, or seeing if those factors work, we can just choose from our list of possible rational zeros. Ideally, we're not going to have a list that's quite this long, but we'll have to actually go through and try them all. So now that we know what a PRZ is and how we can find our list of PRZs, let's look at how we'll use those PRZs to solve the problem that we started with today. We're looking to see where this expression, this polynomial, has zeros, where if I did y equals this, our graph would cross the x-axis. So I'm going to list out my PRZs. Well, it's all the factors of 6. So let's see, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. I think that's everything. I divide by any factors of a leading coefficient, but that leading coefficient is just 1, so there's nothing to divide by in this case. This is my entire list of possibilities. Those 8 numbers are my possible zeros. Those might be the answers to my original question of where would the graph of this polynomial cross the x-axis. All I have to do is figure out which of those 8 would be the solutions. I do that by trial and error. Right? I do that by taking each of these possible solutions, each of these possible zeros, and putting them into a division problem. So like, let's say I want to see if positive 1 is a zero, is a solution here. Well, I would take this polynomial in synthetic division. There's my coefficients. I'd put 1 in the box over here. I'm going to test to see if this is a solution, if this is a zero. Right? Now, as I do this, remember that in order to be a solution, I have to have a remainder of 0. Right? Now, in this case, I have a remainder of -8. So this 1 is not a solution. This is not a solution. Didn't go in evenly, didn't leave me with no remainder. So 1 didn't work. I just throw that aside, I try the next one. Now it's up to you what order you want to try these in. Some people, if positive 1 doesn't work, they go to -1. I like to try the positives first, and then if those positives don't work, go to the negatives. Basically just whatever numbers seem like it'd be easy for you to try in your synthetic division. So I'm going to go to positive 2. Put that in the box. Same expression, same idea, trying to figure out if this is a solution. All right, so when I do my synthetic division again, here, I think I'm going to find good news. And I have good news. I have no remainder. Remainder is 0. What that means is that 2 is a solution. It's one of our roots. It's one of our zeros of this polynomial. So I know that 2 is one of my solutions because there's no remainder. Okay? So now how can I use that information? Well, if 2 is a solution, I got to think, well, if 2 is a solution, what would my factor look like? You know, if I'm breaking this down, I know this would break down into, now remember, if 2 is in the box, this would be x minus 2. All right, because we put the opposite of that number in the box. This would be x squared plus 4x plus 3, and that's how that would break down. So I found my magic factor myself now by trying all the possibilities, all the PRZs, all the possible rational zeros. I found one that works. 2 works as a solution because there's no remainder. Well, that means x minus 2 must have been a factor of that polynomial, leaving me with x squared plus 4x plus 3. And I went ahead and put that on the next slide here because I didn't feel like I'd have enough room to solve it on this one after we did our trial and error. So we know now that this polynomial breaks down into x minus 2 times x squared plus 4x plus 3. We just solved this from here by factoring or using the quadratic formula. This one will factor for me. X plus 1, x plus 3. Solve by setting all of our factors equal to 0 like normal. So I find x equals 2, which I knew already. That was the one that I tried. Then x is negative 1, and x is negative 3. Notice that all three of those solutions were in your PRZs. They were in your list of possibilities because the only rational numbers that can work are in that list. So if you tried negative 1 in the box, you would have gotten a 0 remainder. That would have been a factor, and you could have solved from there. Same if you would have tried negative 3. All you have to do is guess and check until you find one solution. After that, you can go back to the method that we've done before. When we know what that factor is, break this down further and solve from there. Okay? So I guess, maybe we can talk about the graph of this just for a second. Since that was the original question, was where would that graph cross the x-axis? Maybe I'll just kind of go on the board here. And remember we had y equals, was x cubed. Let me go back and look and see what that was. X cubed plus 2x squared minus 5x minus 6. We're trying to sketch the graph of this. Well, now we know a lot of things about this graph. We know the x-intercepts. We know this crosses the x-axis 3 different places. We know it crosses at positive 2, at negative 1, and at negative 3. All right, so we have 3 x-intercepts. You can quickly look and tell what the y-intercept would be. If you plug in 0 for x there, you get negative 6 as your y-intercept. And we also know the end behavior. Since this is an odd degree, it's an x cubed and a positive leading coefficient, we know that as x approaches infinity, y is going to approach infinity. And as x approaches negative infinity, y is going to approach negative infinity. Right? We know our end behavior is going to resemble a straight line with a positive slope. So now we can kind of put all those pieces together and get a pretty good sketch of what that graph would look like. Let's kind of connect going left to right here. And you end up with a good sketch of what that polynomial would look like. Okay? So again, PRZs, look for all the factors of your constant divided by all the factors of your leading coefficient. Use those as your, basically kind of like a word bank and on a vocabulary sheet. You just try one of those in your division. If you find one that's a solution, use that and solve from there. Okay? I believe that's it. I'll see you tomorrow.